Welcome to the Explainer. Today, we're going to dive into a source that offers a very different answer to a question we all think we know the answer to.
So let's just start with this. You probably learned the reason way back in grade school science class. And it seems pretty simple, doesn't it? I mean, you'd think the answer is totally settled.
And yup, there it is, the good old textbook explanation. The idea is that because the Earth is tilted on its axis, our part of the planet is angled more directly at the sun during the summer. This makes the sunlight more concentrated, more focused. And, for most of us, that's the end of the story. Case closed.
Well, the source we're digging into today argues that this common knowledge isn't just incomplete, it's fundamentally flawed. And it proposes a pretty radical alternative for where all that summer heat actually comes from. Okay, so to really get a grip on this new theory, we first need to look at exactly how the author pokes holes in the explanations we all kind of take for granted. So the author kicks things off by looking at the official word from a pretty major source, the Library of Congress. And it's basically the explanation we just covered. A steep angle means the light doesn't spread out as much, so you get more concentrated energy. And boom, more heat. But right away, the author challenges the basic physics of that claim. He argues that a steeper angle of impact would actually cause the light to spread out more, not less. I mean, that's a direct contradiction that questions the very foundation of the whole explanation. And he doesn't stop there. He also takes on two other common arguments. Okay, what about longer daylight hours? Well, he points out that those extra hours are at dawn and dusk, when the sun's heating effect is at its absolute weakest. And the idea that we're closer to the sun in summer, that one's just plain wrong. The Earth is actually closest to the sun during the northern hemisphere's winter. Okay, so this leads to a really key problem he identifies. Heat is infrared, right? Well, the author states that most of the infrared photons from the sun, they're actually blocked by our own ionosphere. So if the direct heat can't get through, it begs the question, where is all that summer warmth really coming from? And that question, it leads to the most pivotal claim in the entire argument. It's an idea that completely flips the conventional model right on its head. He poses a simple but really powerful question to challenge our assumptions. Think about it. If heat just falls from the sky, why is it colder the higher you go? You climb a mountain, you're getting closer to the sun, but it gets colder. That seems backward, right? And this brilliantly illustrates his core premise. He says that most of the heat of the Earth doesn't come down from above, but up from below. The main source of heat is rising from the Earth itself. So where does this upward energy come from? The author's theory says that charge from the solar wind gets pulled in at the poles, cycles all the way through the Earth's core, and then rises back up toward the surface all over the planet. Okay, let's move on and see how this upward flow of energy supposedly creates the incredible heat of summer. This is where we get to the core mechanism he proposes. The author proposes this 5-step process. So first, you've got charge rising up from the Earth's core. Second, you have solar radiation coming down from the sun. Now, the key ingredient here is the third step. The summer's tilt creates the perfect alignment between these two opposing flows. And when those fields align, they reconnect. This reconnection spins everything up, creating this intense burst of energy that we feel as heat. Now, this next part is really interesting because it gives us the formal definition of this central concept. According to the source, magnetic reconnection is what happens when radiation moving in opposite directions gets spun up, which dramatically increases the overall energy levels in an area. It's the engine of this whole process. And he argues this isn't just some isolated theory for Earth's seasons. He actually connects it to other, bigger, unexplained phenomena in physics and astronomy. He suggests this could be behind the magnetism in elements like iron, the absolutely incredible temperatures of the sun's corona, and even the high temps we see in the upper atmospheres of places like Jupiter. So, if this theory were true, what else would we expect to see happening during the summer? What are the broader implications here? Well, according to the source, the increased energy from this magnetic reconnection, it has a second major effect. That extra spin energy that's created doesn't just produce heat. And this brings us to the two key takeaways from the whole theory. First, summer generates more heat because of this field alignment. And second, summer also generates more magnetism. This means summer isn't just a thermal season, but a magnetic one too. And that leaves us with a final, pretty provocative thought. Could summer be a season that we don't just feel, but one that fundamentally changes Earth's magnetic field? Is it possible that summer is more than just a change in temperature, but a whole different energetic state for our planet?